do it without. Hello? Hello? Together? Sorry. Maybe if you don't like this microphone, I can do it without. No? Okay, then do it with it. Because sometimes microphone is expressing too much power. No, I'm very happy that I can present my work of the last month. It was much more work than I expected. But I'm a little bit ashamed because I'm coming from Zurich, and we in the Western world, we know of so many famous Armenian artists, architects, engineers, and of course I cannot compare myself with these brilliant people. And so it's a little bit strange that I'm coming from there and coming to Armenia with this country having a so bright tradition of brilliant work and influence from the eastern side to the west. So let's put that aside. I'm very happy that I can present my work, and I'm also very happy that so many people attended this talk, because I'm not very well known. I did some work in the past. I also presented a paper about object orientation in a conference in Leicester many years ago, but not about this new topic, which took my attention completely, and it some sort of introduced or induced the starting point of a new phase of my life, because we will see until the end of the presentation that we have a lot of work to do, and I can't do it by myself. So let's see what happened. The computer is not interested. So, okay. The topic of this talk is the war of programming languages over? Because we observe lately, in the last 4 years, that new programming languages emerge. For example, Rust and Go, and we have a lot of niche programming languages which are not known to many people, but they have their own qualities. And one of the main topics of this talk will be how to compare or rate the quality of programming languages. But in the first, I have to, at the beginning, I want to say, although I'm 30 years, have 30 years of experience in programming with C++, Java, and other languages, mainly object-oriented languages. Of course, Pascal. I learned Pascal as one of my first languages. This talk is not about programming languages bashing. We all have preferences. We like one programming language more than another, depending on the style of the language, the syntax, whatsoever. But also, I have my own preferences, but this is not about bashing. I want to find an attempt to look in a more engineering way at programming languages. To say something in advance, we all know that the typical process is that a new area is first like an art. Few people understand, have their own ideas, they break path to new grounds, but there is no system, no curriculum, no standard way to teach. So it's a system of gurus or brilliant people who define that. And the next stage in this process is the science. So regularities are analyzed and found, and a system is built, laws or rules are detected and formulated, and the last step in this process is engineering, standard procedures to accomplish something. And we can clearly see this in the area of architecture and constructing of buildings, which is very often compared to software construction. Even the vocabulary is lent from the architecture. And there we have even the split of the more of the art part, which is done by the architectures, and the engineering part, which is done by the building engineers who calculate the thickness of ceilings and the thickness of walls and so on. And in software construction, I think we are still, at least in the area of programming languages, in the phase of that being more an art than a science, and let alone an engineering discipline. So, what did we encounter lately? May the 12th, we had this attack of the WannaCry ransomware, which was quite effective, but not well programmed. So it contained at least one bug, and the damage was not that bad as it could have been. But this is very interesting from the point of view of programming languages and program quality, because this attack was only possible because there was a security hole in the Windows operating system, or maybe in several, at least in Windows 8. This is a screenshot from a Windows 8 occupied computer. Oh, I have to say that most of the material I present is from Wikipedia, because it's very easy to take it from there, but I did a lot of research with Google, of course. Today, I think this is the standard way to go. And I contributed a little bit of my own ideas, of course, but this is from Wikipedia, so not my own computer. Anyway, this was from a Windows 8 computer, which was successfully attacked and occupied, and but this was only possible because of this security hole. And who knows what was the reason of this? Of this security hole. So back in 2014, in fact, the bug introduced was already in OpenSSL. The version is there, March 14th, 2012. It was introduced by a German programmer who committed something not correct. It was a problem with the buffer overflow, programmed in C. We all probably, most of you know that OpenSSL is programmed in C completely. I worked several years with that. It's really huge and very difficult to understand, especially how it is implemented. And so I don't blame anybody that this happened, but we can say this is a clear consequence, straightforward consequence of the way how it is was programmed, or it is programmed. And the strange, or the I would say daunting fact is that it was only discovered more than 2 years later, fortunately by Google security team, which was not had not the intention to do any harm with that. But imagine, more than 2 years the software was in use, and the bug, it's really a very severe bug, which allows a web server to pretend to be someone else, and so to invite people to give their credentials, for example, passwords and so on. And it was only detected after a long time of use. And the last one, which is not related to any bugs, more I would say to any harms, this is a very old edition. at that time very famous publication Byte, which went bankrupt. I don't know when, but before the year 2000, I think. But anyway, already 1993, they had this headline, Fighting Fettware, because they observed that programs were bigger and more complex, and if you make a prognosis about that, then you can easily understand that this would lead to disaster. And what we have then, as a consequence of this observation, Word's law. Word is a professor from ETH, sorry, it's a little bit from my local background, but we come to other people also. And he coined this sentence, software is getting slower more rapidly than hardware becomes faster. I think it's easy to understand, and we don't go in detail, but this book, already published 1991, mentioned this relationship between hardware and software and the speed of development. And we all know Moore's law, which predicted a doubling of processor speed every 18 months. Of course, it's will sooner or later come to an end, but many years this rule or law was correct, and people at that time, former time, expected that software will easily run faster on new generations of computers, but because of the software development and the expansion of new versions being fatter, new versions being fatter than older versions, the software demanded even more processing power than the development of hardware provided. So this is a short story, we won't go into in detail, but he discovered that with a brand new computer and a new version of the software, he could not only even fluently operate the software and had to buy a new one or more RAM. So now we are at Hoare, Tony Hoare, as he is called in short. He said a lot of funny things, I think, and which lays the ground for our talk. Algo 60, this is a predecessor of Pascal, with strong typing, a lot of features which are regarded as safety features. And it's also a clean language. This means that the language has not too many features and not a lot of features which can be used as alternatives. So it's some sort of orthogonal features. One feature is for that, another feature is for that, but you can use the features independently without interaction of the features. And yeah, and it was a little bit funny because he said that obviously the people who designed programming languages did not learn the lessons from the Algo 60 story, because yeah. And also much later, 2002, object orientation was already invented or in use, and he found that still at that time, where there is not a clear discipline which is aimed at making programs flawless or zero defect. So we have a lot of programs with avoidable defects because the people, the programmers, don't follow strong disciplines. They don't, a lot of them don't understand how to prove the correctness of the program. And it's not the fault of the programmers, because I know I'm working for more than 30 years in the business. The time pressure. If you work in a commercial company, then you have time pressure, and finding proofs for correctness needs a lot of time. So we have a lot of buggy software, despite the fact that we know these bugs can be very harmful. And yeah. And I like this especially. There are two ways of constructing software design. One way is to make it so simple that there are obviously no deficiencies, because someone who reads the code immediately understands this is correct, because it's that simple. And we can extend this to the architecture of a system, because we can create levels of abstraction, and this sentence, this statement should be true on every level of abstraction. So, but the other way is to make it so complicated that there are no obvious deficiencies. I like this very much, because really we have open source. Jan already gave a talk about that, and I'm really also an evangelist of open source. But it has open source offers a tremendously wide range of quality. You have open source software you really have almost no chance to understand, because it's so written in a way that it's not obvious if it's correct or not. But there are other examples. So open source fits to this demand of constructing well understandable, easy to understandable and clean software very well. So open source at the former times did not exist, but now I think it's a very good complement to the aim of getting good software, constructing good software. Another short quotes. Yeah, this is more related even to the topic of this talk. The topic is about complexity, and Hoare is stating that Pascal, in a sort, is a very good early example of a language with not too many features, independent features, and small enough that you can, in normal use, you will understand the complete language, but in specialized use, you are even possible to extend the language without getting a huge language nobody will understand. Here also, we have so many. It's about the Ada language. Ada, you may know, was the winner of a project of a competition, advertised or organized by the American Department of Defense, and Ada was built more or less on the grounds of Pascal or Algo, but added a lot of features, and it was very, very difficult to implement the full language standard. And Hoare is criticizing exactly that. The year is always 1980, because the quotes are from his lesson, his talk, after he received the Turing Award. I think this is also very interesting, because this is directly related to the heartbleed bug. You may remember the heartbleed bug was related to a buffer overflow. The C programming language does not provide any control of memory bounds for buffer access. And in short, he reflects the experience with commercial customers who observed in production runs buffer overflows or index violations. And of course, with these tests, every occurrence of every subscript of every subscripted variable was on every occasion checked at runtime against both the upper and lower declared bounds. This costs a lot of computing power, and at that time computing power was very precious. So this way of securing or making a program safe costs a lot of computing power, but the customers denied to have a version of the software without these checks, although this software would be run maybe twice as fast or even more, because they experienced these index violations. So they knew the software contained bugs, and without these checks, these bugs would not be detected when they occurred, but only later when they already did some harm, maybe even disastrous harm. And the consequence of HOR was, in any respectable branch of engineering, failure to observe such elementary precautions would have long been against the law. And we will come again at the end of the talk back to this. And as a side note, this is not related to HOR. I think we should think about a law that requests all components, operating systems, routers, firewalls, web servers, browsers, of the public infrastructure, public IT infrastructure, and those that interacts with them, with these components, which includes, for example, browsers and other programs which have access to the internet in the simplest way, to be checked by a state authority, as it is done, for example, with cars in Western Europe. For example, in Western Europe, you cannot start selling a car without getting a permission from authority from a government, which is, of course, delegated to specialized institutes, which examine the car if the car fulfills the basic requirements for being part of the public transportation system, or of the public traffic system. And if the car does not fulfill, the company is not allowed to start selling this car. And I think with software we should have the same situation, but we don't have. We have operating systems with a lot of bugs. We have browsers, web servers, other software layers, routers, firewalls with bugs, and these bugs can be used to do disastrous harm. So why are programming languages so important? Many people say today, programming languages are not that important. We use these components and that components and we put them together, and a little bit glue code. It's not important if Perl or Python or whatever. But at the end, all boils down to a programming language. Even the firmware of your computer, of your router, is programmed with the programming languages, and installed in the system. So at the end, whatever you look at, the operating system, the libraries you are using, the tools you are using for building your system, the whole architecture, how the system is composed, the communication protocols layers, and as I mentioned, the hardware microcontrolled by software, all is at the end programmed by software and of course written in a certain programming language. Of course, there are different programming languages in use for that, but the programming language is the final state tool for creating this piece of software. And from these pieces, the whole system is built up. So, this is what I already said. So, now, what do you think are criteria, or can be criteria, to select a programming language? Pardon? Market? I think so too, very good. Other votes? Speed? Okay, speed. Pardon? Objective here, do you think, do you mean that if it's an object-oriented language, or? Yeah, I see. Yeah, and so is there already something there which fits in the field? Yes, I think this is a very important thing, because today a lot of programmers don't want to start from scratch. they want to use things already there. But we had another mode. Scalability, okay, this is a more technical aspect. I think, very good answers, but I think the context is important. If you are a soloist by your own, then you can ask yourself, what do I like? What fits, where I'm good in? Functional programming, okay, I don't need to explain this in detail, but of course, what's there, depending upon the goal, depending on the goal I want to achieve, and I look if there is already something there, I will probably take this programming language. A good example of that is the software telecommunication switch Asterisk. You may have heard of it. It's in use by, I think, more than 100,000 companies, and is written in C with a huge layer of macros. I studied this. They have, about 2 years ago, I studied it, and they had a backlog of several hundred bugs and a huge documentation to explain how to cope with this macro layer of C. And in hindsight, nobody would started this project with C, but a few programmers started it, and many other joined, and it was once started with, created with C, and it continued. So probably it's too late to switch to another language. Okay, but if you are a group, then you have other things to respect. For example, people can leave the group, and you have to replace them. So the decision for a programming language should be a little bit more strategic. Don't use a programming language which is only used by a few people, because if someone leaves the group and should be replaced, or the group is expanded and we need more programmers, maybe we don't find them. Of course, what's there also a point for the group decision. And the company, I think, has a very different point of view. The company normally has a history. They have tons of software written by former employees or current employees, so you can't replace them easily. You can't replace that easily, and of course the programmers also. And they even think more strategically what program languages are widespread, because they want to be able to hire programmers to acceptable salary. And of course, what is the future about the language? Who is behind the language? Who is supporting the language? Will the language be there even 10 years or 20 years ahead? Now we are there, what I already explained at the beginning. And I think in the we don't have scientific criteria for selecting a programming language. The criteria we already discussed before are not scientific. Oh, they are okay. If you look at the market, it has some economical point of view or aspect, but not a true genuine scientific aspect from the point of view of the programming language. So, are hardly reliable. Yeah, and I think you may know that Donald E. Knuth started in the 90s, I think, a series of books about computing, and he named the series The Art of Pun? Yeah. Exactly, The Art of Computer Programming. And volume, he aimed for 7 volumes, I think, and he could finish so far, I think, 5. But the title expresses that at that time, at least, computer programming was more an art than an engineering discipline. And this is especially true when it comes to programming languages, because for other areas we have tools. We can, for example, compare two programs in efficiency. For example, two IP stacks. We can compare two implementations regarding the efficiency, how fast they process packages, and we can also compare operating systems. For example, with web server, we install the same web server on Windows and on Linux and compare the throughput. So this is true scientific or true engineering approach, but with comparing programming languages, so as far as I understand, we don't have reliable criteria. And yeah, and even the economical criterion for software companies have the problem that we cannot calculate, that we don't have useful software matrices, or matrix, sorry, it's a mistake, to calculate the alternatives of strategic decisions. If a company decides, okay, this is not a good programming language, but which one should we take? Then it's almost impossible to calculate the amount of work which is necessary to migrate. So, and I think this is scandal. As an engineer, this is really a pain that we don't have a clear systematic approach to these questions. And there is even no useful criterion to rate the complexity of a program, which is not the same as to compare programming languages, but maybe can be used. We come to this soon, in a few minutes. But as mentioned before, we need something to calculate the time it would need to understand the program. For a new programmer, for example, someone leaves the company, another one comes, then how much time will the new guy or lady need to understand the program or the modules? And I think this is a very hard task to develop such a metric, and it shows that also we are probably very high educated compared to many other communities. Also in our community, the typical human being attitude is prevailing, that we are happy to solve problems. We expect that they can be solved, but not attack or not try to solve problems which should be solved, but without guarantee to solve it really. So what do we have? Short, I won't go too in detail, but we have a little bit. We have the cyclomatic complexity of a program, which is very easy to measure. This is also from Wikipedia. But the problem is here. I used this by myself, but it leads sometimes to very strange results. You can get for one module a very high number, even so the module is easy to understand. So, and there is no proven or statistical based connection between this complexity number and the time needed to understand. So I think from engineering point of view, this is not very helpful. And there's another established complexity measure, the Halstead. This is a little bit more complicated, and it's also a little bit strange because, for example, the number of delivered and expected bugs, and this is very strange because if you analyze the program and you iron out the bugs, then this number will not change. So it's a little bit strange. At least there should be something like a versioning count or how many people are involved included in the calculation. Otherwise, I think it's not feasible. Okay, now, but this is only about program complexity. The next step is how do we get from program complexity to programming language complexity? And I made an assumption. Compilers and interpreters of programming languages are reasonably efficient implemented. So the people who write compilers and interpreters are smart people, and they write efficient code. And with that assumption, it should be a sensible approach to measure the complexity of a programming language by measuring the complexity of the parser, the front-end part used to implement the compiler or interpreter of this program language. Because the complexity of this front-end part is directly related to the complexity of the language. And if it's reasonably efficient implemented, then this measure should be helpful. But again, we don't have a generally accepted metric for program complexity. So what should we do? What can we do? What else can we do? As a small example, what would be very helpful, this is a page from the Natural Language Institute of the ETH Zurich, and they provide for each language, natural language course, characteristic stamp or map where they state, unfortunately it's in German, it's a little bit strange because I switched to English. You see all the names are in English and the explanation is still in German. But to make it short, the important thing is here. This is a description what you will have learned at the end of the course. The course is 90 minutes per week, and this is what you will have learned. And I think this would be great if we would have something similar or the same for programming languages. Tutorial explaining or stating what an average programmer with a certain knowledge base, for example, fluent in Java and Python as an example, would need to work through the tutorial. But we don't have this for most of the programming languages. So the tutorial approach, I would name this the tutorial approach A. So getting a clear statement from the designer of the tutorial, how much time will an average programmer need to understand the language with help of the tutorial. The tutorial approach B is very simple. Size in number of words and number of items explained. This gives a rough estimate of the complexity of the programming language. Because if you have only 20 items to explain, or if you have 60 items to explain, then it's expected that the programming language with the 60 items is more complex than the one with the 20 items. Also, the size of the tutorial in number of words can give a clear hint about the complexity or ease of understandability of the language. Okay, another approach could be size of the standardization document, or size of the publication which introduced the language. Most languages are introduced by the person who designed the language. For example, Eiffel was introduced by Bertrand Meyer with the well-known book Object-Oriented Software Construction, and many others. Even C++ was introduced by Strauss-Job with a paper explaining the language and why the design decisions, why the language is the way it is. And comparing the size of these introducing document and explaining document could be a way to compare the complexity of the languages. So another approach could be the number of tokens, and this is very interesting, I think, because it was done by a Russian professor of applied mathematics in his book on compiler construction and language complexity. And but I think it's a good approach. But this one man, one vote approach has a problem that each token of the language vocabulary has the same influence on the count. So each token is counted as one, independently if the language construct which is related to this token is complex or simple. For example, in C you have the curly brackets for open and closing a block, and these are counted the same as the switch statement, which is much more complicated. So my proposal, and this we are now at the heart of my presentation, because I thought a lot how get a reliable or at least helpful metric for complexity. And I propose in this presentation that the complexity should be directly related, linearly related to the code size of the front end of the implementation. Of course, this approach has disadvantages. It cannot be used if the front end cannot be clearly separated. We have with Eiffel, I had the problem. And if the generated code is not one of the widespread formats, so you cannot compare them. But fortunately, we have an advantage. This approach works for several, or I would say the most important widespread languages, for example, for C++, C of course also, Java and several other. Basically, it works for all languages which can be compiled with the GNU compiler suite. And because this the GNU compiler suite generates with the same backend code for example, the Intel architecture, and so you have object file formats in the same of the same type for each language which can be compiled with this compiler. And most of the important languages can compile with that compiler. So, pain and pleasure learning a programming language. I think if one decides to learn a programming language, one should expect to get something out of it besides being a better employee. But the basic aspect is the question how efficient one would program with the language just learned. And I would rephrase this to the question about the power of the language. Because before I had lengthy talked about the complexity of the language. But complexity itself can be necessary if I needed this complexity to solve certain problems, and if it's justified, if I get enough power out of this complexity. And so the proposal is the power of the language shall be the size of the implementation of its compiler or interpreter backend. So the proposals, both proposals are very simple. We have the front end and we have the back end. And we have the same compiler suite, for example, the GNU compiler suite, and we can compare the size of the front end object files, the sum of this size, and the sum of the sizes of the back end object files. So, and now we are in the position to come from complexity and power to quality. And the proposal is, because we need a metric, the proposal is the quality shall be the quotient of the power and complexity. So we divide the number of the power by the number of the complexity. So the quotient will be as bigger as more power and as less complexity the language has. So, and now we are very prosaic, second last slide. I calculated these qualities numbers, and I tell you, this is very, very tedious, needs a lot of time, and boils down to a few numbers. And I failed to calculate this for Eiffel, for example, because I want to go in detail. I tried several additional languages. I could not finish, or I could not even reach the end of the calculation. And this is related to what I said in the beginning. I will, in the next month, or maybe years, step by step, analyze programming languages with this approach and publish it on a web page. I already are in contact with a guy who is registering websites, and we are thinking about the domain name, and expect in about 4 months we will have our own domain and starting publishing not only the numbers, also the details how we come to these numbers. Java, I have to say, I did this with the GCJ compiler, which is not in the current Java version, but I expect that the quotient won't change much. So, conclusion, complexity is evil. Compatibility is evil. I did not expand on that, but I want to give this to the audience, because many programming languages suffer from being compatible with older ones, or at least pretending to be compatible. For example, using a similar syntax as another programming language. And this is not good. This is some sort of slowing down the progress of the development. So we also need regulations for software. Probably a lot of people won't like that, but I'm now be sure that we need that. And we need software metrics, and I invite the people, all of you, to contribute to this with ideas and code. Because I think after I started working on that already last year, maybe, I don't, but I searched many hours for software metrics, and I didn't find any useful, especially complexity and complexity of programming languages. And we need this to be a major engineering discipline. And we need competition. We have, you mentioned that it's very important for a programming language who is behind the programming language. And it's no coincidence if we look back here. Maybe most of you don't know, but this was backed up by the American telephone and telegraph, AT&T company. So they were behind this extension of the programming language C. Rust is backed up by the Mozilla Foundation. They announced that they will, the new generation of the famous Firefox browser, rewrite in Rust, if I'm maybe right. Pardon? Pardon? Server is the name. Yes, thanks a lot. And Java is backed up, was backed up originally by Sun, a very powerful company who went almost bankrupt and was bought by Oracle, but Oracle continued, and they implemented even a Java virtual machine on their on its database management system, Oracle, which is the cash cow for the company, as far as I understand. So it's also a major player, and of course, Google or Alphabet is playing on every area it's imaginable. So they wanted to have their own programming language also. And strange enough, 2 weeks ago, I found the first announcement of job advertisement where Go was a requirement. So slowly but surely, this language will hit the market. And it probably won't go away soon because Google has, or Alphabet has enough money. And so, why Oberon? Oberon is the, Oberon 2 is niche language. I mentioned at the beginning, we have niche languages. I'm very familiar with that because I learned it at the ETH and Wirt. I mentioned it before with the quote of this hardware and software relationship development speed. He designed that language and it's incredibly efficient. It's a very small language and has a very good quotient or quality index. Of course, probably the index could be even higher because Wirt already designed a new version with less features and probably the same power. But anyway, this is a very, very good value. And I would be happy to invite some of you, or even all, for the talk tomorrow, where we have a closer look at C++, Java, and Oberon 2, because C++ and Java are really widespread. And both suffer from insurmountable problems, problems you cannot avoid. To say one thing about Java, Java is a very good language designed after the principles of Oberon, but there is one big problem so far. Java is only running in the virtual machine. So you cannot write an operating system with Java. So most operating systems I know are all, sorry, it's the last slide. Oh, second last. All operating systems beside one or two I know of are written in C. So especially Windows and Linux, and Mac OS is FreeBSD, which is also C. So we have no operating system implemented in a safe programming language. So we have to expect a lot of bugs and vulnerabilities in these operating systems. And okay, this is one aspect. And tomorrow we will have the chance, or I will try to compare these three languages in more detail and to give some workshop-like hands-on experience working with Oberon 2 development system and compilation speed, and how we can dock at other existing systems. This is important. If you decide to use a niche language independently, as good as it might be, you need a sound way, a reliable way to interface to existing software. Thanks.